Multibody system dynamics in 15 minutes. Here's the first real theoretical video that is about description of rigid bodies. Before entering the description of rigid bodies, I would like to spend a few minutes to explain you how is actually a multibody system. To that end, let's look at this slide here. By the definition, the multibody system is a system that consists of multiple bodies, and these multiple bodies are connected together via constraints. So now, if we look at the example system A shown here, that obviously consists of multiple bodies. So here's a first, second, and third moving bodies. And these bodies are connected together via constraints. And this time the constraints are the mathematical definition of revolute joint. I have here 1, 2, 3 revolute joints, and in addition I have here translational joint that forces piston to travel back and forth in this surface. So this is clearly a multibody system. In multibody system dynamics, we do not make any assumption regarding the magnitude of rotation. So the rotations can be large. And an example where there is a large rotation in the body is a pendulum. So in the multibody system dynamics, the pendulum can get started here and it can travel all the way to another end. And when describing something like that, you have to describe large rotation. Now, if you're dealing with large rotation and you build the equation of motion such that large rotation is accounted, generally, there is no analytical solution available. Instead, we have to solve the equation of motion using numerical methods. So what about the system B here? System B here, that too consists of multiple bodies. So I have here box number 1, 2, and 3. But these boxes are not coupled together via constraints or joints. Instead, these are coupled together with the spring elements. Now the spring elements most probably will introduce the motion if I take the hold of the first box and forcing it to go downwards. But the motion will be force dependent. Whereas in a multibody system, if I take a hold of the piston body and I'm asking it to travel to left hand side, other bodies that are connection rod and the crankshaft have to follow to the constraints. For this reason, this system here, the B, strictly speaking, is not the multibody system. I could, however, solve this by using a multibody system dynamics, but there may be other formulations that are more efficient to solve this kind of problem, such as finite element method.